So welcome everybody to this latest video on 162 Maths, and in this video we will go through the AQA AS Maths exam of 2018, Paper 1, Section B, which is the mechanics section. Now before we get started, a little reminder that there will be a question breakdown of Section B in the description, so if you struggled or couldn't do any of the questions you can see which topic it relates to. There will also be a link to the 162 Maths contents page, which gives you easy access to all the videos of lessons on the AS Maths curriculum, along with A2 and links to other AS paper walkthroughs. Question 11. A ball initially at rest is dropped from a height of 40 metres above the ground. Calculate the speed of the ball when it reaches the ground. So we need to look at parts of Suvat. So we get the letters for Suvat and then just take the information from the question. So the value of S is 40 metres. It is initially at rest, so has an initial speed of 0. We want to calculate the speed when it reaches the ground. So those are unknown, and we're told that gravity is 9.8. So we're going to use, with the Suvat equation, we're going to use v squared equals u squared plus 2as, and we can then work out from the numbers given. V squared is equal to 0 squared plus 2 times a, which is 9.8, times s, which is 40. Remember that to find v we would need to square root the answer. So 2 times 9.8 times 40 square rooted gives a value of 28 metres per second. Question 12. An object of mass 5 kilograms is moving in a straight line. As a result of experiencing a forward force of F newtons and a resistant force of R newtons, it accelerates at 0.6 metres per second squared. Which of the following is correct? So if we were to take our object and it experiences a forward force of F newtons, a resistance force of R newtons, and it has acceleration of 0.6 metres per second squared. If we were to use F equals ma for this question, our overall F, or resultant F, is going to be our forward force minus any backwards forces, is equal to the mass times acceleration. 5 times 0.6 is equal to 3. So now we need to find our answer. F minus R equals 3. Question 13. A vehicle which begins at rest at point P is travelling in a straight line. For the first 4 seconds, the vehicle moves with constant acceleration 0.75 metres per second squared. For the next 5 seconds, the vehicle moves with a constant acceleration of minus 1.2 metres per second squared. The vehicle then immediately stops accelerating and travels a further 33 metres at constant speed. Part A, draw a velocity time graph for this journey on the grid below. We need to get the information from the description. So we've got first 4 seconds, so that is here our first 4 seconds. We've got a constant acceleration, meaning that the line has got to be a straight line that we're going to draw, so it's not a curved line, it's a straight line, and it has a starting point at 0, 0, and we need it to go to 4 seconds, and that would give us a constant acceleration straight line up to 3, and we can see that our gradient of this line would be 3/4 or 0.75. For the next part then, we have the next 5 seconds, so that would take us up to 9 seconds. We've got a constant acceleration, so straight line again, and this time it's negative 1.2. Now negative 1.2 is the same as negative 6/5, so it's equivalent of negative 6/5. So for the next 5 seconds, the velocity is going to decrease by 6. So we can draw another straight line from our last point. It needs to be going to 9 seconds, and it's going to decrease by 6. So there we have now a gradient of minus 1.2. And for the last part then, it says that for the last part, the distance travelled is 33 metres. It's at a constant speed, so it stops accelerating, meaning that the gradient is 0. So that means we're going to draw a horizontal line to take the 33 metre distance, and what we need to find is how to get 33 metres from an area, because area is the same as the distance. So it's, at the moment, if we think of this as 3 for the width of the rectangle that we're going to draw, it's got to be a horizontal line, because that gives us constant speed, and we need to have this line needs to be going to 20 in the x-axis or the horizontal axis. That would give us a area of 3 times by 11, which is 33 metres. So that gives us that piece of information and finishes off the diagram. So if I get rid of those highlighted parts, that is part A. Part B says find the distance of the car from P after 20 seconds. In order to find the distance on a velocity time graph, we need to find the areas that are between the graph and the horizontal axes. So we have 2 areas. If we split the above area into a triangle and the below area into a trapezium, or we could use the split here and make a triangle and the rectangle, because we're already told that that has a distance of 33 metres. So we want to find the area of our first triangle, which is half base times height, so 6.5 times by 3. That gives us an answer of 9.75. Our second triangle is half base times height, that's 2.5 times 3, which is 3.75, and our third area we know already is 33. So taking a look at the distance travelled, we want to find our value of 9.75 and subtract away 3.75 and 33. So 9.75 subtract 3.75 subtract 33. And that gives us an answer of minus 27, and this value here is negative, which means it is 27 metres as a distance, and that will be a distance from P. Question 14. 2 particles of mass 1.8 kilograms and 1.2 kilograms are connected by a light inextensible string over a smooth peg. Part A. Initially, the particles are held at rest or 1.5 metres above horizontal ground, and the string between them is taut. The particles are released from rest. Find the time taken for the 1.8 kilogram particle to reach the ground. So if you consider what's happening in their diagram, we have the 1.8 1.8 kilograms, so 1.8 g force acting downwards, and tension in this string acting upwards. And the same on the other side, we've got 1.2 times by g acts as a force acting downwards and tension acting upwards. And we know that from the description the 1.8 kilogram is going to move downwards, so we've got the acceleration acting downwards in the 1.8 kilogram side, and the same acceleration value is going to work upwards with the 1.2 kilogram side. So we need to set up a system of simultaneous equations for each of these two particles. So if the first particle is going to move downwards, the 1.8 kilogram particle is going to move downwards, so its force is in the direction, so 1.8 g minus any forces in the opposite direction, so tension is equal to mass times by acceleration. Then we have the second simultaneous equation, so the force tension moving upwards minus the force downwards, 1.2 g, is equal to mass times acceleration. So we've got a set of simultaneous equations there. We want to work out the acceleration value because in part A it talks about the time taken for the particle to reach the ground. So this is a Suvat question. So we want to have all the parts for Suvat. So if we set this up, so S, U, V, A and T, we know that the distance travelled is 1.5 metres. We know that this is initially at rest. We want to work out the time taken to get to the bottom. So our acceleration is a value we can find through the simultaneous equation. So there's ways of working out your value of A. You could first of all add these two equations together. By adding the two equations together, it eliminates the variable t. So we get 1.8 add minus 1.2, that would be 0.6 g. And if we add 1.8 and 1.2 lots of A, we get 3a. We can then do 0.6 times g, which is given in the top of the question, divide by 3 to give us a value of A, which is 1.962, and that would be meters per second squared. So we can take that value and pop that into this here. Now we've got a Suvat equation. We can use S equals ut plus half at squared. So substituting those values in and then finding that value for t. So 1.5 is equal to 0 times by t, which would be 0 anyway, so it's half times a times by t squared, and we want to solve for t, so we can remove the times by half, so we can either divide by half or multiply by 2, then divide by 1.962, and remember to square root the answer. So by square rooting you are going to get t is equal to 1.24 seconds. For part B, it says state one assumption you have made in answering part A. So if we look back at the starting point, it tells us some of these assumptions, so we need to make sure we don't use the same assumptions. So it says connected by a light, inextensible string, over a smooth peg, they're particles. So we can't use any of these as the answer for part B, so we need to look at the diagram, see what's not been used as an assumption. If the particle is going to go from its resting point to hit the ground, so it's got to travel all the way to the bottom here, we have to assume something about the string and the fact that the string is long enough to allow the 1.8 kilogram particle to reach the ground before the 1.2 kilogram particle reaches the pulley. because if the string isn't long enough, then that's going to affect the question. So our assumption is to do with the string being long enough for the 1.8 kilogram particle to reach the ground before the 1.2 kilogram particle reaches the pulley. Question 15. A cyclist Laura is travelling in a straight line on a horizontal road at a constant speed of 25 kilometers per hour. A second cyclist, Jason, is riding closely and directly behind Laura. He is also moving with a constant speed of 25 kilometers per hour. The driving force applied by Jason is likely to be less than the driving force applied by Laura. Explain why. And that would be due to less air resistance experienced. So if Jason is riding directly behind Laura, then there's going to be less air resistance on him, therefore he would have less driving force. Part B. Jason has a problem with stops, but Laura continues at the same constant speed. Laura sees an accident 40 metres ahead, so she stops pedalling and applies the brakes. She experienced a total resistance force of 40 newtons. Laura and her cycle have a combined mass of 64 kilograms. Determine whether Laura stops before reaching the accident. So we need to take this to be a Suvat question. So we want to know the distance travelled by Laura. We have got an initial speed, which is 25 kilometers per hour. We want to know if she stopped in time, I would have a final speed of 0. We haven't got acceleration just yet, and we haven't got a time. So we need to find the acceleration. So if we set up the diagram where the resistance force is 40 newtons, acting against the direction that Laura is travelling at the moment. So we use F equals ma, and we can work out A from here. So negative 40 is equal to mass of 64 times acceleration, and so minus 40 divided by 64 is minus 0.625 for acceleration. So now we have this value. Now we need to take a look at the fact that it says that the speed is 25 kilometers per hour. We need to use the units of meters per second, so we need to do a conversion of 25 kilometers per hour into meters per second, and that would be 6.94 meters per second. So you can either do that calculation by hand, so changing that to 25,000 meters divided by an hour of 3,600 seconds, or you can use your calculator. They have conversion buttons which will convert 25 kilometers per hour into 6.94 meters per second. Okay, using the Suvat, we want to solve for s, so we're going to use v squared equals u squared plus 2as. We need to substitute these values in, and solve for s. What we get in the end is s is equal to 38.5 meters. So if we compare that to the accident, which is 40 meters ahead, the question is, will Laura stop in time before the accident? She's going to travel 38.5 meters before stopping, so our conclusion is yes, she stops before the accident. In part 2, it's a state one assumption you have made that could affect your answer to the first part, and it's the stating that if she sees the accident, there's always thinking time before seeing the accident and applying the brakes. So there's that thinking time that would be added on. So we have to assume that there was no thinking time for the conclusion that she would stop before the accident. Question 16. A remote controlled toy car is moving over a horizontal surface. It moves in a straight line through a point A. The toy is initially at the point with a displacement 3 meters from A. Its velocity v meters per second at time t seconds is defined by v equals 0.06 bracket 2 plus t minus t squared. Part A, find an expression for displacement r meters of the toy from A at time t. So we have got velocity, which is going to be a variable acceleration topic question, so that involves the differentiation and integration. So we want to go from velocity to displacement. So in order to do that, we are going to integrate the velocity with respect to time to get the displacement. So we need to integrate 0.06 lots of 2 plus t minus t squared with respect to t. You can multiply out the bracket, so we get 0.12 plus 0.06t minus 0.06t squared, and we're going to integrate this with respect to t. If we do that, we get 0.12t, we get 0.06t squared divided by 2 and 0.06t cubed divided by 3 and a constant of integration. We can take the terms that have got fractions and simplify those. So 0.12t plus 0.03t squared minus 0.02t cubed. And we go back to the question and look at the information about the initially has a displacement of 3 meters from A. So we can go in and replace s with 3 at t equals 0. So 3 is equal to 0 plus 0 plus 0 plus c. So c is equal to 3. So our final answer for our expression is s equals 0.12t plus 0.03t squared minus 0.02t cubed plus 3. Part B says at time t equals 2 seconds, the toy launches a ball which travels directly upwards with initial speed of 3.43 meters per second. Find the time taken for the ball to reach its highest point. So we're back to a Suvat question. So again, finding those parts of the question which we can fill in. So at time t equals 2 seconds, the toy launches directly upwards. So we have got an initial speed of 3.43. We have a final velocity of 0 because that would be when the ball reaches its maximum height, its highest point. Acceleration is going to work against the ball at minus 9.8, and the question is about the time. So we're going to use v equals u plus at and solve for t. So substituting values in and rearranging, solving for t, we get t is equal to 0.35 seconds.